Bismillahirrahmanirrahim. uh, Welcome back, my dear students. We have 39 lecture. The course title is Viscous Fluid 2 and the code of the course is 741. I am Dr. Kamran, the instructor of this course. Uh, we are uh, discussing the domain decomposition method uh, and the application of domain decomposition method in ODs and PDs, and as we discussed in previous lecture, we discussed the analysis on the homogeneous problems on linear PDs, and in previous lectures we discussed that how we can calculate the general form of the linear PDEs of the heat equations if we are taking the linear operator in terms of t and the linear operators in terms of x. So in both cases the solution for the domain decomposition method or for the linear PDEs using a domain decomposition method has the same solution when you are using the linear operator in terms of t or the linear operator in terms of x. So in both cases the solution is exactly the same. So this is exactly the beauty of this method, uh, and one can say that this is a very powerful tool for the calculation of different sort of differential or ODEs. So here in this lecture we are going to discuss the inhomogeneous problems, that how ADM can solve the inhomogeneous problem. So the equation is exactly the same with the slight change in the source term. The boundary condition are exactly the same, but they are non-zero, um, but they are inhomogeneous in nature. So uh, this is exactly the case that you can apply the separation of variables, the Laplace transform, the Fourier transform for the solution of heat equation. But here ADM can also give you a very uh, uh, interesting solution, and that solution is almost exact solution because we have a series in hand, and that series is rapidly converged to its final form. So ADM is a powerful tool, and you can solve all the questions, all the linear PDEs, the non-linear ODEs using this tool. So now the problem here is inhomogeneous heat equation, and you already know that what is exactly the inhomogeneous PDEs or ODEs. So I'm not going to discuss the inhomogeneous form. This is your job to understand that what is exactly the inhomogeneous problem. So here we have exactly a heat equation in which we have only this term, this function is an extra term. These boundary conditions are extra, a bit different from the above examples or from the previous examples which we already discussed in the previous lectures, and the initial condition is exactly equal to the one of the trigonometric function cos x. So uh, as it is discussed in this paragraph, you can see here that a great advantage of the decomposition method is that it can provide solution to PDEs homogeneous or inhomogeneous in nature without any need to use any transformation formula as required by the method of separation of variables. What we are doing in the method of separation of variables, in separation of variables you divide uh, the, the unknown terms. For example, if u is the unknown term u of xt, so in separation of variables, what you are doing, you separate or you decompose this unknown functions into uh, uh, single variable function. One is capital X is a function of X, and Y is another uh, capital Y, which is function of T. So in separation of variables, we are separating the unknown functions or the multivariable functions in a single variable functions. But in a domain decomposition method, we do not need such decomposition. We are straightforward applying the linear operator, and then we assume that that linear operator is invertible and the process is going on in in final form. We have the series of the original problem in hand, and that is exactly a very powerful solution for that for that equation. So now here we have this inhomogeneous problem. So this is exactly inhomogeneous because once you add extra function with the heat equations, and if the boundary condition are non-zero, then you can say that type of functions or that type of ODEs or PDEs are inhomogeneous. So again the same scenario you are choosing here, or the equations can be written in operator form. L of t of u of xt is equal to L of x of u of xt plus sine x, where this is a general function f of x, and it could be anything. It you can write it can be cos x, it can be tan x. So here it is sine x. So the next step is we assume that L of t power minus 1 exists for this LT, and the operator is here is LT, where LT is equal to partial by partial of t. This is exactly the linear operator for this problem. And as we discussed before, the process is exactly the same, that we applying the invertible operator on this equations on both sides of this equation. So once you apply, this is vanished. For example, let me apply here. This is L inverse L of a t, and you can apply L inverse on this term as well and on this term as well. So once you apply, they are identical, they vanished. So you will have exactly one variable. This exactly is this one, u of xt is equal to, and this is now the zeroth order solution you can find. You just integrate this sine x uh, in terms of from 0 to x, so it give you the zeroth order form, and this is the invertible operator applying on the other terms of the equation. The next step is we replace this unknown function by a series of function, which is this form. This is exactly that series, and where there is u of xt, replace this u of xt by this series. So you can see here in this equations we have only these two um, terms involved in u of xt. So this is now exactly the series form of that above equation. So once you expand this series, so u naught of x of t is equal to this one. This is zeroth order solution you can see here, and u1 of xt is the integration of this term from 0 to 2. So once you integrate this term, you will have exactly this solution. This is exactly u1 of t, this is u2 of t, and once you combine all these terms, so you will have exactly this solution. So now the assignment or the homework here is that try this problem using the uh, separation of variable method, this one, the separation of variable method, and compare your solution of separation of variables with this ADM solution. That what is exactly the difference between the two methods. uh, uh, आपने ये देखना है कि आपको ये सेपरेशन ऑफ वेरिएबल कौन सा सोल्यूशन दे रहा है, कैसा सोल्यूशन दे रहा है, और फिर उसको आपने क्या करना है, एडीएम के साथ कंपेयर करना है. तो you will see how which one is the strong method and which one is the best method. So this is your homework, and I hope that you will submit this homework in next class. Thank you.